Hello students. So let's try to solve some problem from special theory of relativity. And this problem is mainly from the relative speed. And these are some PYQ question of net JRF. So let us try to go for a step by step some problem. So basic formula we are just going to use in this particular set of problem is all about, we can just go for this notation. So we have some inertial frame S. With respect to that inertial frame, the another frame is moving, is another frame is S dash, which is moving with respect to S is V, and the velocity of S dash with respect to S is V. So velocity of S dash with respect to S is V. And there is some particle, and you can assume this is my particle, and which is moving with respect to S dash is, let's say, ux dash, obviously in I cap direction. So we are just using for one dimensional case here. And this velocity of particle with respect to S dash is equal to some ux dash. And we have to, in each and every case, we will just calculate velocity of particle with respect to S, and which will be, let's say, ux, and this value is equal to ux dash plus v 1 plus ux dash v upon c square. So if you can write this particular thing, then velocity of particle with respect to s will follow this symmetry. The velocity of particle with respect to s dash plus velocity of s dash with respect to s, and 1 plus velocity of particle with respect to s dash into velocity of s dash with respect to s upon c square. So we have to follow this particular symmetry, and we will just try to solve three different problem into different year, and you will see that every time we can use this particular formulation and we can solve this. Okay, so I am just keeping this thing here, and in this part I will try to solve the different problems. So first problem is in net JRF. So this is your net JRF 2018, and this is in June exam actually. So this is in June exam. The problem is very simple. There is some frame, and this is inertial frame, and let's say this frame is sigma. I am always using the some inertial frame is sigma. If nothing is given, what is S and what is S dash? Actually, we have to figure out what is S and S dash according to our convenience. So, anyway, so let's try to go for this one. So with respect to some inertial frame sigma, there is a particle is moving with velocity v, and this is my a particle, and this is given with respect to sigma. The another particle is moving opposite to this particular b, and this has same velocity v, but direction is opposite. And we have to calculate actually the magnitude part. So we have to calculate velocity of a with respect to b. So in the examination, they have asked what will be speed of A as will seen from the rest frame of B. So that means we have to calculate velocity of A with respect to B. So we will just try to make this particular problem, try to transform this particular problem into this form, and we will just try to solve it. So let's try to go for this. So first it is given the velocity of A with respect to sigma is, let's say, V, and velocity of b with respect to sigma is, let's say, minus v, and this is in I cap direction. This is minus v in I cap direction. And if it is given, then obviously we can write velocity of sigma with respect to a is minus v in I cap direction, and velocity of sigma with respect to b is plus v in I cap direction. And here we are, I am just using the concept that I will always try to see the whole thing from S frame. So I will just put myself on S frame, and A will be my particle. So A will be my particle. Then obviously sigma is my S dash frame, because this will just connect between A and between S and particle. So this will be the buffer between this. So you have this particular thing. So A is my particle. B is my, sorry, sigma is my S dash, A is my particle, sigma is my S dash, and B is my S frame. This is my S dash, and sigma is my S dash, and B is my, so B is my S. So out of this thing, we have to first calculate what is velocity of S dash with respect to S. So for there, so obviously we have to take this one according to my notation. So velocity of S dash with respect to S is equal to V. Obviously it is in I cap direction. So we will use the Lorentz transformation. And so first, if we are using this one, so this is not necessary to use. And next we have to calculate velocity of particle with respect to S dash. So velocity of particle with respect to S dash is this one. So we are just, this is nothing but ux dash, and that particular is V. And we have to calculate velocity of particle with respect to S. So according to, we have just convert each and everything in this form. And yes, this will be nothing but ux. So we have ux is equal to ux dash plus V 1 plus ux dash V upon c square. So from here, you can easily put ux dash is V. Velocity of V x dash with respect to S, that is V is equal to V. So here we will put V plus V 1 plus V into V upon c square. So yes, this will be 2V 1 plus V square upon c square. So this will be the answer. This is a very straightforward question, but yes, we have to understand the formulation, and we can just compare each and everything from here, and we can give the answer. So this is the one of the very wonderful problem asked in NET JRF 2018. So let's go for another problem, and this is also very interesting one. So let's try to solve this one. So again, I am keeping this thing in front, and then I will just go for the notation, and we can easily solve this particular thing. So let's try to go for next problem. So this is all our mother equation in today's problem. So we will always use this thing. So let's try to go for this. So let me clean my board first, and then we will just go for another one. Okay. So in this problem, this is in December 2017. So NET JRF, NET December 2017. So this is a wonderful problem. It's an awesome one. So there is a glass plate, and in this glass plate, there is a 2 point. Let's say this point is A and this point is B. And these points is moving with respect to observer with velocity 0.3 c. And we can assume there is observer. Then let's say this observer is O. And from A to B, there is light signal is going from A to B, and the refractive index of glass plate is given 1.5. So mu is of the glass plate is 1.5. So in this problem, it is given that what will be speed of this light pulse with respect to observer in the glass. So that means when light is going from A to B, what will be speed measured by observer with what will be speed of measured by observer to this particular light pulse in the glass plate. So if glass plate will remain stationary, or if observer will sit on glass plate, then speed of light is, so velocity of light with respect to glass plate is nothing but c upon n, or c upon mu you can put, and this mu is nothing but 1 upon 1 by 1.5. So this will be c upon 1.5. And the velocity of glass plate with respect to observer. So velocity of glass plate with respect to observer is nothing but 0.3 c. So obviously both speed is relativistic in nature. Both are moving in the comparable situation of the speed of light. What we have to do, we have to just calculate velocity of light with respect to observer, obviously in the glass plate. So what will be this particular thing? So here I can assume my observer is at S frame. Light will be something like particle, and then my glass plate will be my S dash. So I can assume this is my S frame, this is my S dash, and this is given with respect to, we know what will the speed of light with respect to S dash means in the rest frame of glass plate, that is nothing but c upon 1.5. So in this situation, so glass plate is S dash, light is my particle, and observer is my S frame, glass plate is S dash. So first thing we have calculated, velocity of S dash with respect to S is v, and that is nothing but 0.3 c. And next is velocity of particle with respect to glass plate is nothing but ux dash, and this will be c upon 1.5. And we have to calculate velocity of particle, which is actually light, with respect to s, that is your ux, and we have to calculate it. Again, we are just reframe our this whole problem into this form, and we can easily calculate ux is equal to ux dash plus v 1 plus ux dash v upon c square. So now we have to put all these values, and when we are just going to put this value is equal to ux dash is equal to c upon 1.5, and this is 0.3 c, and we have 1 plus c upon 1.5 into 0.3 c by c square. And when we are calculate, and when you will able to calculate this all thing, I have calculated with myself, and this value is equal to actually 0.81 c. So this will be the answer. So it's a very wonderful problem. Again, you can see I rearrange my problem in this formulation. So every time you have to rearrange your problem. What is your S, what is your S dash, and what is your particle? And then you can easily solve this problem. Let's try to go for one more problem. This is also a very nice one, and this is very conceptual problem. So let's go for next one. Okay, so this is more or less a straightforward question, and this is in June 2015. So this is in June net JRF question. So this is net JRF, CSIR net JRF 2015. The problem is very simple. So there is a 3 frame. The frame A is there. Another frame is B is there. Another frame is C is there. So there are 3 frames. C is moving with respect to B with the speed, and it is given C by 10. So velocity of C with respect to B is C by 10. And B is moving with respect to A is something C by 2. So velocity of B with respect to A is equal to C by 2. And we have to calculate velocity of C with respect to A. This is very straightforward. So obviously, I can assume A is my S frame, C is my particle. So A is my S frame, then B will be my S dash frame, B will be my S dash frame, C will be my particle. So we can easily transform, write each and everything in our form. So first we have to write velocity of S dash with respect to S, and in our notation, this is V, and this value is equal to what? C by 2. And then we have to write velocity of particle with respect to S dash, and this is nothing but ux dash, and in this problem this will be c by 10, and we have to calculate velocity of particle with respect to s, and that is your ux. And then again we will go for this particular symmetry, and we have ux is equal to ux dash plus v 1 plus ux dash v upon c square. And now you can just put all this value I have calculated with myself. So c by 2 plus c by 10, and you have 1 plus c by 2 into c by 10 by c square. And when you will calculate this particular thing, you will get 4c by 7. So just you can do this calculation with yourself and try to do this calculation in a very smart way such that you can get the appropriate answer. So friends, we have just solved these three problems, and these all three problems are based on same concept, but they all are different system. But finally what we have done, we have just reorganized our problem. We have just formulate our problem into this form. So it is very necessary that you know the formulation, you know the notation, and how you are using this notation to solve your problem. So these three problem is three different type problem which you can revise before your examination. So thank you. Just do practice with yourself and let me know if if you have any suggestion. Thank you.